Welcome to this channel. Last video talked about how deleting the Il11ra1 gene can positively impact metabolism. In this video, we delve deeper into the role of IL-11 in aging. Building on our previous discussion about IL-11 deletion and senescence in humans, we focus on the impact of IL-11 deletion on male mice. Discover how the absence of IL-11 affects body composition, metabolism, muscle strength, and overall health span. We also explore the potential benefits of anti-IL-11 therapy in reversing age-related decline. Learn about the effects of IL-11 on factors like body weight, fat mass, muscle mass, glucose metabolism, frailty, and fibrosis. Deletion of IL-11 in male mice. Detrimental changes in body habitus, body weight, fat mass, lean mass, and frailty scores, driven by tremor, coat condition, and fur loss, were mitigated and body temperatures were mildly increased in old male IL-11 knockout mice. Muscle strength was higher in both young and old IL-11 knockout mice compared with age-matched wild-type controls, as seen for female mice. GTT and ITT profiles of old IL-11 knockout mice were similar to those of young mice, whereas those of old wild-type controls were impaired. Metabolic cage analysis revealed that the respiratory exchange ratio, RR, was overall higher in old IL-11 knockout mice compared with old wild-type mice. After a period of starvation, refeeding resulted in a greater increase of RER in old IL-11 knockout mice, consistent with better metabolic flexibility. Whereas old IL-11 knockout mice were leaner and weighed less than wild-type controls, they consumed more food and had similar levels of locomotor activity. Calorie-losing enteropathy of IL-11 knockout mice was excluded by bomb calorimetry. Sarcopenia was apparent in the muscle of old wild-type mice, and this effect was less pronounced in old IL-11 knockout mice, which exhibited greater indexed muscle mass even when young, as seen for female mice. Indexed liver weights were similar between mice of both genotypes. As for female mice, perhaps the most notable beneficial difference associated with loss of IL-11 function in old male mice was seen for VW80 mass, whereas BAT mass was similar across genotypes and ages. An incidental finding of enlarged seminal vesicles, an idiosyncratic age-specific phenomenon in old male mice, was more common in old wild-type mice compared with old IL-11 knockout mice. Wild-type, 11 out of 15, IL-11 knockout, 1 out of 14, p equals 0.0003. Anti-IL-11 therapy in old male mice. Studies of germline genetic loss of function on health span and/or lifespan should be complemented by interventions in late life only to identify phenotypes that are carried through from younger animals and for translational relevance. This is pertinent to the current study, in which some beneficial effects of IL-11 loss of function, such as increased muscle mass and strength, are apparent even in young IL-11 deleted mice. To achieve this goal, we administered a neutralizing IL-11 antibody, X203, or IgG control to aged mice and studied health span indices. Compared with controls, mice receiving X203 from 75 to 100 weeks of age progressively lost body weight that was defined by a reduction in indexed fat mass. Impaired glucose metabolism was apparent across experimental groups at study start that was improved in mice receiving X203, whereas IgG had no effect. Frailty scores were mildly increased across experimental groups at study initiation. Over the study period, mice receiving no treatment or IgG exhibited frailty progression, for example, tremor and gait disorder, whereas those on X203 did not. Muscle strengths of 100-week-old mice receiving anti-IL-11 were higher than age-matched controls receiving IgG or untreated, and also higher than those of 75-week-old mice at the start of the experiment. After 6 weeks of antibody administration, mice were studied in metabolic cages. The RER of mice receiving X203 was higher than that of IgG-treated mice but lower than that of a cohort of young mice, suggesting that X203 slows age-associated metabolic inflexibility. Administration of X203 was associated with higher core temperatures and increased food intake, whereas locomotor activity levels and fecal caloric densities were similar between study groups. Mice left untreated or given IgG had increased serum cholesterol, triglycerides, and IL-6 by study end, which were collectively lowered by X203 therapy to below the levels at 75 weeks of age. Over the course of the experiment, markers of liver damage, hepatic triglyceride content and indexed liver mass increased in untreated and IgG control mice, whereas these phenotypes were either improved or reduced in mice receiving X203. There was a reduction in indexed VW80 in liver mass and an increase in indexed muscle mass in 100-week-old mice receiving X203, compared with both age-matched controls and 75-week-old mice. Mice receiving X203 had diminished SCWAT and an increase in BAT. The age-specific phenotype of enlarged seminal vesicles in male mice was again diminished by IL-11 loss of function, IgG, 8 out of 13, X203, 2 out of 12, p equals 0.022. Fibrosis is a canonical feature of aging and a hallmark of senescence, and IL-11 is known to be profibrotic in human cells and in young adult mice. We quantified fibrosis in aged VW80, skeletal muscle, and livers of old mice across experimental groups, which showed reversal of tissue fibrosis across organs of mice receiving X203. Compared with 75-week-old mice, VW80 from mice receiving IgG for 25 weeks had increased activation of the IL-11 mTORC1 axis and higher expression of senescence markers. By contrast, mice receiving X203 had reduced ERK-mTOR activity and decreased expression of P21 and P16. 100-week-old untreated and IgG-treated mice had telomere attrition and a reduction in mtDNA copy number, which were not seen in X203-treated mice. And there you have it. We've delved into the fascinating world of IL-11 in male mice. From the detrimental effects of IL-11 deletion to the potential benefits of targeting it with anti-IL-11 therapy, the data is compelling. We've explored how IL-11 impacts body composition, metabolism, muscle strength, and even age-related conditions like frailty and fibrosis. It's clear that IL-11 plays a significant role in aging and overall health. If you found this video informative, please give it a thumbs up and subscribe for more updates on our research. Share your thoughts and questions in the comments below. We're eager to hear your feedback. Stay tuned for our next video where we'll explore the exciting potential of anti-IL-11 therapy as a way to combat age-related decline in terms of female mice. Thanks for watching.